Assalamu alaikum, sir.
Walaikum assalam. We were doing sketches, and last time we made this sketch. As mentioned earlier, the sketches is our premier topic, and look at this example, a very famous example. Many times in the exam, a ball is thrown upward and the ball came back. A ball is thrown upward and the ball came back, and it's a displacement time sketch. It is a displacement time sketch when the ball is traveling upward. When the ball is traveling upward, the displacement is also increasing, but with a decreasing gradient. When the ball reaches the maximum height, the displacement graph also reaches the maximum height. When the ball begins to fall down, look at this animation again, and it's a very good concept to understand. The displacement time graph is initially increasing and now it's back to zero. So when a ball is thrown upward and you draw a tangent at any point, the gradient will give you the velocity. The gradient will give you the velocity.
Okay.
So a ball is thrown upward. There is no air resistance in the upward motion. Velocity is positive, and for the downward motion, velocity is negative. It is a displacement time sketch. It is a displacement time sketch, and there is no air resistance in this case.
There's no air resistance, sir.
There is no air resistance. That is why you can see A acceleration is equal to G.
Okay.
So when
So
the
can you
ball
show,
is traveling, yes,
so
sir.
can you show example number 1 again? I just want to make sure that I did the right sketch
Wait, what example?
for describing sketches. Like this is example number 2, yeah? Okay. Okay. Okay, thank you.
Now, in the upward motion, for the upward motion, displacement increases, D increases. For the downward motion, displacement decreases. You have to copy this example. This is example number 2.
Okay, sir. So acceleration is negative throughout, yeah?
Acceleration is negative throughout the motion.
Okay. So after we're done with kinematics, can you do waves unit for waves?
Waves. Have they
Yeah.
started waves in school?
No, it's because like we just started units and quantities, but the next chapter that we're gonna do is gonna be waves. So like,
Are you sure they're going to start waves?
yeah.
Have you got the pattern of syllabus? The syllabus line?
So like they're gonna be starting it with like the easier chapters first. So like they're like, oh, we're gonna do waves first.
But waves is not an easy chapter. That's a very strange thing. But have they given you that document of what chapters they are doing in first semester, first round?
They're gonna print. They said to print it out yourselves for physics, but for
Okay.
other subjects they're giving it.
Okay, so we have thrown a ball upward. and it reaches the maximum height where the velocity has become zero. So if you draw a tangent at the maximum point, if you draw a tangent at the turning point, gradient would be zero because the tangent is parallel to x-axis.
Done, sir.
Now, I'm putting a question here. A sphere is released and falls. Its initial acceleration reduces until it eventually begins to travel at constant velocity, constant terminal velocity. Which displacement time graph best represent the motion of the sphere? Now, remember that it's falling down. It's falling down means displacement would be decreasing. Its initial acceleration reduces until eventually it begins to travel at constant speed. Now, you have to read the question carefully. It's coming down. So he can trap you by the word reduces. Displacement always is measured from the starting point. So if you start from the vertical downward motion, it is not necessary that displacement decreases. When it is coming down, displacement would be increasing because you started from the top. If you start from the top, if you throw something downward, look, this is a ball and it is coming down. When it is falling down, it means displacement would be increasing.
Okay, okay.
The first point is there, displacement is increasing. When displacement is increasing, it means the first two sketches A and B are out of question. The other two sketches need support now, need hint.
Okay, so is it, sir? Is it gonna be C?
No, you have to think again. We need
Sir,
a
sir,
just
sir.
you
It's
can
a D. D. I'm in D. I'm in D, sir. Sir,
yes.
it's D, yeah?
Now we need explanation because C means displacement increases and later displacement becomes constant. D means initially the displacement increases and later the velocity becomes constant. How I can say velocity becomes constant?
The green becomes constant.
The gradient becomes constant. This is a very important point to understand that actually whenever you deal with a question like this, you should technically look on all options. A-level MCQs are very tricky. So if I go for this tradition, it means displacement decreases to zero. It means that. Here, it also means displacement decreases to zero. Now, it's a very important thing to understand then what is the difference between A and B. In A, displacement is decreasing at a decreasing rate. In B, displacement is decreasing at an increasing rate. Gradient is increasing. Acha, what about D? Displacement increases. Here, D becomes constant and velocity becomes zero. How I can say velocity becomes zero?
Sir, it's because like the displacement becomes horizontal.
Yes,
Like it
the
doesn't
line
move.
becomes horizontal. When a line becomes horizontal, it means the gradient is zero.
Yeah.
And in the D, displacement increases and then velocity is, how I can say velocity is constant? Because the line has a constant gradient. Because the
Yes.
line has a constant gradient.
Yes, sir.
So I have made reference notes here. Remember, for every question of this type, you have to check, double check all the options. And whenever it's a displacement time graph, whenever it is a displacement time graph, the gradient is velocity. When it is a displacement time graph, the gradient is velocity. Now, look at this sketch. A ball is thrown upward, later it falls down, air resistance is present, the ball eventually reaches terminal velocity. This is a very important sketch. Terminal velocity is one of their favorite topics. Now you have to copy this screen. I'm just coming for namaz. I'm going copy it. I'm just coming. Give a new heading, speed or velocity time sketches. Give a new heading, speed or velocity time sketches. This is our next heading. Now, first point I'm putting here, speed or velocity time. Gradient shows acceleration. Area shows the distance traveled. You have to copy this screen now. Let me know if you have copied it.
Okay, sir.
Arima, have you copied it?
Yes, and
Now we have made the main sketches. We have now made the main sketches form. Velocity time graphs are constant acceleration, constant velocity, constant deceleration, increasing acceleration, decreasing acceleration. These terminologies we have all already have discussed. So these are our, remember the rule, if you make a memory of the main sketches, which I did in my last class, then they will obviously change the axes, velocity time, distance time, mass against acceleration, etc. But you can interpret every sketch if you remember those important main sheets. You know, you have to copy this screen now.
Okay, sir.
These are the sketches, but never try to memorize them.
Okay, sir.
done, sir.
Okay, Saad, let me know once you are done with the sketch.
Okay, sir.
Have you done it?
No, 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 not yet. Done, sir.
Now, look at this thing that the object is released and it's a case of uniform velocity. This ball is falling with uniform acceleration. Look at this line, straight line. Straight line means velocity is increasing at a constant rate. Straight line means gradient is constant. Now, this is their favorite question. It was used to come in O level also. In A level, in AS level, unit conversion is their favorite trick. Unit conversion is their favorite trick. Read the question, and you know the acceleration is the gradient. Acceleration is the gradient. So you need to find gradient. So now try to work it out.
Okay, sir. Sir, is it D?
Okay, and remember what you got. First, you have to make a unit conversion, and then you should do the calculation. The answer is D. Saad, what points you have taken?
On the graph, I
Yes, I think
took I took it like the ends, like
hmm.
100, 100, 110 kilometers per hour and 4 seconds.
So basically you took 110 on y-axis. Is it 110 or it should be 105? The first line, first box.
Oh, sorry, 105, 105, my bad.
Because it's 50 reaching there, na? So two boxes gap. So it
No, no,
should.
no. I got 105, but like
And after
me reading, I
105,
read it wrong.
you have converted 105 into meter per second.
Yeah,
How much
you
is that?
multi it's like 29, sir.
Sorry,
It's like 29, 1 second.
you are saying 29.
Yeah, 29.2.
When when a line is parallel to y-axis, gradient is infinite. When a line is parallel to y-axis, gradient is infinite. Look at this graph. The graph is losing the gradient. It means acceleration is decreasing. This means acceleration is decreasing. Now we are putting our next concept. The trend of acceleration is the trend of resultant force. Why this is so? Because resultant force is directly proportional to acceleration. These are called connected graphs. Now, what happens in the paper that they can ask you to find or comment on resultant force? Apparently, it would be difficult. Why it would be difficult? Because acceleration is coming, but the link acceleration, the trend of acceleration is the trend of resultant force. Now you have to copy this screen.
Okay, so can you explain it more though?
First copy it. These are called connected graphs. The graph itself is not telling anything about resultant force. The graph itself is actually commenting on acceleration. But we have a connection that the trend of acceleration, is the trend of resultant force. And resultant force is directly proportional to acceleration. So we read the graph. we read the given graph. This is the graph, for example. The graph says acceleration is decreasing. So I will say, after this logic, I will say resultant force is decreasing. How I can say resultant force is decreasing from this graph? Because actually, what is decreasing?
Gradient.
Acceleration, which is the gradient. When acceleration is decreasing, it means resultant force is also decreasing. Whatever the trend in acceleration is there, the same trend will be valid for resultant force. Now you have to copy this screen.
Done, sir.
Done, sir.
A raindrop falls vertically from rest in air. The variation with time of the speed of the raindrop shown in the graph. Whenever you come across a graph in A level, you always remember, first of all, see what is on y-axis, what is on x-axis. Never look at the shape. Once you see that, the step 2 is to see what is the gradient or what is the area. So the y-axis is speed, x-axis is time. What would be the gradient?
Distance.
No. Acceleration?
Gradient is acceleration.
Okay. Hello, sir.
Yes. Gradient is acceleration. Now, one thing is clear that the graph is bending and then the graph is becoming straight. Look at the options. Which statement about the raindrop is connected? These are called theory MCQs. Now, theory MCQs are always very challenging. Why they are challenging? That you have to read every option. They are so close that normally if you read it with normal view, you will not find the difference. Look at the first part. At point X, the raindrop has an acceleration of 9.8. 9.8 is a constant acceleration. And if you look at X, the graph is bending. So it cannot be uniform acceleration.
Okay.
The point X, the raindrop has an acceleration 9.8. At point X, it's a curve. It's not a straight line. Secondly, he already has said it's falling through air. The variation by time of the raindrop is shown in the graph, falls vertically. It's a raindrop. For a raindrop, air resistance can't be negligible. At point Z, the force on the raindrop due to air resistance has reached its maximum value, and so the acceleration of the raindrop has reached its maximum value. It's a very technical concept. When something is falling through air, its acceleration actually decreases. I think you can identify this part of the graph. Here, the velocity has become constant and acceleration has become 0. This is the position Z. Now, I have marked the point on the graph. Is it B can be right or B is wrong?
It's B, sir.
Read B again. At point Z, the force on the raindrop due to resistance has reached its maximum value. Look at the marking I have made. What is the acceleration at Z?
Sir, the acceleration at Z is
Look
0.
at the 0. And it's a case of terminal velocity. The velocity at Z is actually 0, but he says maximum. So it means this is wrong. At point Z, the force due to air resistance, the word maximum is a problem. At point Z, the force due to air resistance is equal and opposite to the weight of the raindrop. So speed of the raindrop is 0. Look at this line. Speed has become 0 or speed is constant?
Speed is constant.
So the resultant force on the raindrop at point Y is less than the resultant force on the raindrop at point X.
Yes, sir.
What about D part?
So D is like the gradient at X is more. So like I don't think it can be D. Because the acceleration at at x is more
So this is the way they always trap you. You have to read it carefully. All other options were already cancelled out. Elimination method, O-level physics. All other options we checked, they were not working, and he was making small traps. The languages were very close. The resultant force on the raindrop at point Y is less than the resultant force on the raindrop at point X. So if you look at the screen, it's a case of terminal velocity. When something is falling through air, what is the concept? When something is falling through air, resultant force decreases, acceleration decreases until they both become zero. I repeat the main concept. When something is falling through air, acceleration decreases, resultant force decreases until resultant force becomes zero, acceleration becomes zero, and velocity becomes terminal. So it means acceleration at x will be greater than acceleration at y, and acceleration at z will be zero.
Okay, sir.
So this is terminal velocity. I took terminal velocity for an example because terminal velocity is their main concept. They always talk about terminal velocity. Terminal velocity means velocity becomes constant and this is called the case of terminal velocity. So I want to repeat that very important concept that the answer is D. Why? Because acceleration when something is falling through air. So I want to make this concept in a final form again because that concept is very important. Something is falling through air. Now, this is one of the most repeated concept in our AS physics. It was a very important concept in O-level also. But in A-level, it is famous that this concept comes every year. When something is falling through air, resultant force decreases, acceleration also decreases. Resultant force eventually becomes zero and acceleration also becomes zero. At this point, velocity becomes constant, which is called terminal velocity. Now copy this screen.
Okay, sir. Sir, I'm pretty sure we did this.
Sorry.
We did this diagram, I'm pretty
Yes, not this diagram. We did it in another format. It was a big paragraph and a boxes with it. But this concept is so important that it has to be discussed at, see, Cambridge says that discuss this concept in a laboratory, show people what is terminal velocity. So they consider it the king of concepts, and it comes every year. So that's why I'm writing it again. I had given you a paragraph, whole paragraph on it in inverted commas.
Yes, sir.
But this happens, some concepts. Do you remember Ohm's law? How much it was important in O level?
Yeah.
And it used to come every year. Similar here. Ohm's law is similarly important here. It comes every year. So CI pattern, some concepts are for every year. Okay, Arima, have you copied it?
Yes, sir.
Okay, Saad, have you copied it?
Yes, sir.
Good. Now I move to my next concept. Velocity as a vector can become negative. So now in A level, you will find very, very challenging sketches because of their negative portion. Now, this is a straight line. Straight line means uniform acceleration, but it's a U-turn case. How come I say it's a U-turn case? Because velocity is becoming negative. Now copy this screen.
So this is uniform acceleration, yeah?
This is how it is uniform acceleration, because line is straight. When a graph has a straight line, it means constant gradient.
Yes, sir.
Look at, sorry, have you copied it?
Yes,
Not
sir.
yes, sir.
Good. Now look at this concept. It's a U-turn case. It's a U-turn case. And I have marked the same letters A, B, C. And look at the letters here. Look at the screen. Can you see the velocity is 0 at point B?
Yeah. Yes, sir.
Now copy this screen.
Done, sir.
Okay. I have shared some homework also. I have given homework files, so try to do them.
Yeah, you did. Interruptions, sir.
I will wait for you people that if you can